Hello Internet, today I have a couple of cards for you. First one is nvidia 1070 Ti that came in pieces. So let's take it apart and see what's wrong. Once inside, immediately I see this card produced its own set of balls right there. And it also has a fried memory inductor, which I think means only one thing: dead core and dead memory. But there's only one way to find out, is by removing the coil out of the way and measuring its pads. If short is on the left, memory is dead. With 8 ohms on the left, memory is 100% dead, but the core may have survived. One way to confirm this is to remove all the memory chips. Memory removed, let's check for resistance, and we have 42 ohms. That means the core is dead. We can also check the memory chips themselves, and it shows 150 ohms, which means these memory chips are 150 times dead. There should be 120 kilo ohms instead. Next on the list is a 2080 Ti Founders Edition that came with no cover and the wrong set of screws that are all different size. Hopefully this isn't the worst problem with this card, but we won't know until we take it apart and do some basic diagnostics. Card came with custom pads, one of which was folded, and also a lot of residue from old pads spread all over. Okay, let's do some basic measurements and see if we find a source of our problem. Kilo ohms on 12 volt, mega ohms on 3.3, that's rather high. Another 12 volt line here. 6 ohms on PEX. Short circuit on 1.8 volt. 12K on 5 volt rail, USB-C 12K. The rest of those three are 12 volt inductors, and we have a memory with 41 ohms, and the memory we have here is micron. Okay, main problem area is the short circuit on 1.8 volt, which powers the core and memory. Right now what I want to know is which end of the inductor that short is coming from. And it looks like we have a short on the load side, which is a very bad sign, but let's not give up. According to the board view, this pad contacts with the MOSFET, which on this board is not present. Then it makes connection with several capacitors around the board, and one can only guess which at this point. What I'm going to do now is to solder a wire to this pad so I can supply voltage to this rail, and we'll look around the thermal camera and hoping to find a hot spot. After searching for long enough, I was able to find one small capacitor on the back, right there. One or both of these caps are short, so let's replace both of them to make our life a little easier. And once we had them removed, let's verify that the short circuit is gone. 2 kilo ohms, and the short removal is confirmed. Great job, team. Right, so let's remove this ugly wire, solder the coil back on, and use the board view to figure out the value of those capacitors. And it looks like it's 0.47 microfarad is what I will be taking from the donor card, which was gratefully donated by a viewer like you. Thank you. Double check the resistance. Now let's power on the card and see if we get any voltages. Do we have 1.8 volt or not? We do. Giggity goo. Which means we have 5 volt and memory and core, and obviously PAX is also there. A quick check of the data lines show that we should be okay. And finally the time came to plug the card in and see if we get a picture. Windows began to load drivers and the display is frozen, and we are greeted with this weird message I've never seen before. Okay, let's run the memory test and see if it passes. While the test is running, if you pay close attention to the blocks, you can see we're about to get a fail, and we did. So let's have a look at the report, and it says we have 2 bad chips. And believe it or not, that's good news. This card has a hope of survival. Now let's have a close look at those chips. I think I have a couple of those in stock, so let's put them on. And before I attempted to replace the chips, I found this. Plastic film was not peeled off the pad. I wonder if that's what led to a blown capacitor. In any case, these chips are about to get replaced. Chips are done. Let's run the memory test again, and this time it fails on the different chips. And why is that? Simple. We have early Micron chips made in 2018. They start with a number 8 at the top. I replaced the bad ones with 2019 chips, as you can see, and those give no errors. This means only one thing. Every remaining chip on this card has to be replaced. And due to cost of replacing every chip is not in the owner's favor, the owner agreed to donate this card to me because it made no financial sense to pay for chips and repair. Which means I'm going to replace these chips at my own expense and hopefully get this card working again. Sell it on eBay and maybe make extra 50 bucks. What's annoying about these cards is that the bottom chips are glued with some kind of resin that's not easily removed. In my previous attempts, I tried to use special knives and all sorts of chemicals, but none of those methods really worked. Instead, what I'm going to do is rather simple. I will cut the resin away with the soldering tip, and then tear out the chip from the board using high temperatures. That will ensure that I do not rip any pads. But I will also have to solder quite a few components back on the board because most of them will be removed. With everything replaced, I ran the memory test again, and this time we get a pass. And at this moment, card is already assembled and running some tests, and as you can see, all is well. Hopefully I can sell it so I can get my money back, at least for the memory, but that's a problem for another day. As for you, this is it for now, and I'll see you later. Goodbye.